I always try and tell my sister and my dad, who are not bad people, but they're both completely polar opposites on political stuff. I said, you know what really works well? And they're like, no. I said, you guys don't talk about political stuff. Then you don't argue. Yeah, but no, there's no yeah buts. And so I've had to make a rule for my sister and my dad. Just know that if someone is getting under your skin, you could say, I'm going to continue this conversation at a later time, and either or both of you have to walk out. And they're like, that'd probably be easier things in life. I'm like, I don't know how I'm 51 and dad's 74 and sister's 46. I didn't figure that out, but I just figured that out this morning, so it's not a big deal. All right, so again, we started with 7-1. We're talking about the chi-square test. Okay, and this really has to do with when you are looking at probabilities of certain things. Yesterday's example, we had 40 boxes of cereal that we had gotten, and we were talking about there was some sort of baseball card in the boxes. So we had purchased 40 boxes. Okay, we observed that we had these numbers of cards that we had gotten. So we had 11, 7, 6, 9, and 7 together. That would add up to 40. And then you have an expected, if everything was fair, you should have 8 of each card if you had grabbed the 40 boxes, if there was an equal likelihood of each card being put in. If you only put one card in and then you put 600 of another in, obviously that changes things. But you don't know. They haven't told you that any of these are harder to find in the box of cereal than the other. Okay, so we're not really going to be evaluating much. We're just going to create this kind of table. The next example talks about, and it's on page 45 of your notes, the distribution of blood types across the world is well known and as follows. Okay, now we have been testing blood types for a long time, and there's certain things that we know about blood types and who can take which blood, and it's always, a benefit to, if you do know your blood type, they can always do a fast test if you ever need blood in the hospital. It's a very fast test that ascertains what kind of blood type is known. So they know that takes place. So it looks like, as far as this goes, that type AB blood is the least likely blood to come across if you had people. It doesn't mean you couldn't come across two people and both have AB blood. It's just it's least likely. Okay, so then this is what we have established of what's going on in the world. Okay, just through taking a look, collecting a lot of data, doesn't mean that, hey, we know that Chris Stirrup is A positive or type A blood. It's just different stuff. So then we go and we create a sample that we want to know if this all worked out. So our sample for the O was 95%, and this was 200 people of our sample in Colorado. We found that A was, these weren't percents, I'm sorry. It was just out of our 200 people, 95 had type O, 77 had type A, type B was 23%, and type A, or not percent. None of these were percents. This is just the number of people have. We can easily find the percent by going 95 divided by 200 and move the decimal 2 places right, 77 divided by 200, and so on and so forth. Okay, so if we talked about our null and our alternative, our null hypothesis here would be blood types equal, and then our null, or our alternatives, our alternative that blood types are not equal. Okay? So One's just saying, hey, they're all equal. The other one says they're not equal. If A, B, or O, A, B, and A, B were all equal, you'd have 25%, 25%, 25%, 25%. Okay? So once we start going through this, we can create another table along with what we had. So we had the blood type. So we have O, A, B, and AB. And then we had observed with our 200 people that you had 95, 77, 23, and 5. Then there was an expected. This came from world data, okay, that 90, 80, 22, and 8. Let's see where that came from. Okay, so now, where did these numbers just come from? Do you kind of see where that math took place? So this is what they had said. They said that 45% had this. So what they would have done is they would have went 0.45 times 200 to get the 90. And this would have been, we had the percent of 40%. So they would have taken 0.40 times the 200 to get the 80. And we would have known that this was 11% of the population. So what they would have done is 0.11 times the 200. And then this would have been 4%. So this would have been 0.04 times the 200 to give us the 8. That's where the expected were. So now if you look at it, it said, okay, of our observations, we had 95 of our people who had type O blood. We would have expected only 90% to have that if we had done a random sample. Our observation gave us 77 people who had type A blood. We would have expected that to be 80%. Our type B blood, we found that 23% of our sample had, or 23 people in our sample had it. We expected only 22 if we had selected 200, and then 5 and 8. Okay? So our observed counts are a little bit different than the expected counts. But is there evidence, just by looking at this, that we made an error or the world was wrong? I mean, so think about this. There's what? 7.5 billion people on the planet, maybe 8 billion. I mean, we could probably look it up and get a pretty accurate count. But let's 7 point something. Yeah, I mean, there's a lot of people. That's just currently. But I would bet you they started, and we could probably look up this information. They probably started realizing different types of blood types, I'd say probably back in 1915, over 100 years ago. I'm just speculating. I can't give you the exact. But there might have been some sort of test that they were starting to realize that with different RH factors, that created different types of blood. So how many people, what was the summation of people? Let's just say 100 years ago. Obviously, for people from 100 years ago, some might be living because they're really old, and some haven't. But how many people you'd be talking about if you're talking about 7.7 billion people right now, plus all the people who had already passed who would have been living back 100 years ago up to this date? You're talking about maybe 10 to 11 billion people. But then we took a sample out of Colorado, even though it was a random sample out of Colorado, to get data that was close. So there's nothing, in my opinion, at this point to say that perhaps the world information was incorrect because we took a random sample of people in Denver. Okay, there might be some of these different things might have taken place just due to where people, however long people have been on Earth, where they live. Like, if you lived in a really cold environment, maybe those people are more likely to have type O blood than people who live in a warmer environment might have AB. Now, of course, because of migration of peoples and people who are, having children with people of other races, ethnicities, all those kind of things, then you start having different things of your children. But I mean, those types of blood might have been different 10,000 years ago. You might have I'm going to country or continent A and saying, hey, and I realized we'd have to go back in time because they didn't have technology back then to go check that. But they might have found that particular region had only that type of blood because the lineage of the people. But it is what it is. So our observed counts were somewhat different than are expected. But it's really hard to say that we have evidence right now. We don't have any tests in place to say this is right or wrong. Okay? So we can evaluate this in the future of our content, but that's really all I have for today. The assignment's pretty easy. Yeah.
I'm just wondering, like, what we're gonna expect to define. Like, are we gonna be like given like the percentage and then the sample and then like what we expect to define?
Yeah, I mean, so like assignment 7.1 that I'm gonna assign you talks about a fast food restaurant. It says a sample of 160 sales show 102 hamburgers, 34 cheeseburgers, 24 bacon burgers. So you're creating this kind of graph, and that's about it. You're making the chart. You create your null and your alternative, so it is either equal to the expected value or not equal to. Then you talk about the zodiac signs.
And we're doing this tonight.
Yeah, that'll be what tonight's is. So it's just basically tonight's homework is you read what's given, you create your null and your alternative, and then you create some sort of grid to it. And you just practice, see how you do. So I would say page 125 and 126 would be pretty fair game to try. You have 10 minutes to get at least a small start on it, and then I'll check that off for tomorrow. But there'll be time tomorrow as well too. If you need more time on the test, again, told you I'm taking care of you. As I'm getting them in, I will try and get them graded. So I hopefully will have everything that you have told me, hey, I'm done. I hope to have that graded by tomorrow morning before you come to class. I only got, did I get Thursdays or Fridays graded in the grade book? Thursday, okay. So, but that's what I got. So, all right. So you.